Now let's go into the second principle, the open-closed principle. In short, this principle states that a class should be open for extension, but it should be closed for modification. Let's take a simple example here. We have the payment processor class. It has a function called process payment. It takes in the payment type and it takes the payment amount. Now if the payment type is credit card, we will call a particular subfunction. If the payment type is PayPal, we'll call this particular private function. Same for Bitcoin. And then finally, we raise an error if the payment type is unknown. And the usage now is we instantiate the payment processor and we say payment process should be a credit card and we call it. I would encourage at this point to pause the video and try to identify what are the limitations of this code. And now that we are back, these are the things that I could identify. The payment processor class needs to be modified time and again and again and again. So for example, if we have a new payment type called debit card, we'll have to write another if statement if payment type is equal to debit card and then create a method similar to this in this class. So this class, which should be a pretty stable class, it is open for modification. Another limitation that I could identify is the process payment method itself. Now this is the main method and it is very prone to become bloated. Say if we add n number of more payment methods, this process payment method is going to be a long if-else ladder. And then finally, unit testing individual private methods is a nightmare. There is only one public method, that is the process payment method, and we'll have to write extensive unit tests for each of these different flows. This is one solution out of many. In this case, we'll use inheritance. Now, we can declare a payment method as an abstract base class, and we say that this interface should implement the process method. The process method should take in the amount. And now based on this payment method, we can create the credit card payment method, we can create PayPal payment and Bitcoin payment. And finally, the payment processor class now itself. The main function remains the same, process payment. However, now we will pass directly the payment method of type payment method and the amount here. And then in the main class, we can simply call payment method dot process the amount. The usage here is going to be we first declare the main payment processor and then we can declare or create any kind of payment methods that we want here. And for each payment method, we can pass in that payment method along with the amount to the main class, that is the process payment. Now in this case, the payment processor class does not need to be modified again and again. If we see here, it only expects a payment method to have this process method, and the process method is defined in this interface in the payment method. Another good thing that has happened is that we have separated concerns of payment processing and payment method. And now, say tomorrow, if we want to add a new payment method, something like a debit card, we can definitely extend this method, the payment method. And then the third one is unit testing is now much more simpler for each individual payment methods. We can write robust unit tests for this. As again, Is this the best way? Now, in this example, we have created three concrete classes and one base class. And in the real world, this might add some more complexity to our project. Another question that we need to answer ourselves is the overhead worth it? If we know that the system is rarely going to change. Now, for example, payment methods, how many times are they going to change really? But this principle does add some overhead rather to a straightforward code base.